we are going for the next heading called as seed. So we have completed fruit in the last class. Now we are starting with the word seed. The seeds are formed after fertilization. So here after fertilization, seeds are formed. Seeds are formed. So here the word fertilization is nothing but it is the fusion of male gamete and female gamete. So the male gamete, female gamete is fused to give rise to a fertilization, and that gives rise to seed. So in the last class I have mentioned about the ovaries develops. The ovaries develops into fruits, whereas the ovule develops into seeds. So usually ovary is giving rise to a fruit, the ovule is giving rise to a seed, that is called as seed. After fertilization, the seeds are produced. Next, the study of seed. The study of seeds is called as spermatology. It is also called as spermology. So here, the spermology is nothing but it is the study of seeds. So here, the seed has the presence of, we are going to indicate, the study of seeds is called as spermology. The seed has the presence of seed coat and embryo. Seed has the presence of seed coat and embryo. Embryo is made up of, embryo has embryonal axis, and one cotyledon in monocots like maize. So here there is a presence of one cotyledon. So that can be noticed in the maize as well as in the wheat. We see that there is a presence of one cotyledon, or it has two cotyledons. Two cotyledons in dichots. So here in a dicot we see that there is a presence of P gram. In alness there is a presence of two cotyledons like this. After fertilization, seeds are being formed. The ovary is giving rise to a fruit. The ovule is giving rise to a seed. The study of seed is called as spermology. The seed has the presence of seed coat and embryo. The embryo has embryonal axis. So this embryonal axis has radicle and plumule. Radicle and plumule. And it has one cotyledon in a monocots, example maize and wheat, and two cotyledons in the dicot P and gram. So we are starting with the next heading called as structure of a dicot seed or dicotyledous seed. Structure of a dicot seed or dicotyledous seed. So here the seed has the presence of seed coat. So outer covering of seed is called seed coat. Outer covering of the seed is called as seed coat. This seed coat is always developed from the integuments. Developed from the integuments of ovule. So, at the time of fertilization, once the fertilization is over, the male gamete and female gamete is fused, the integuments of the ovule is giving rise to seed coat. It is giving rise to seed coat. So the seed coat is of two layers. Seed coat is, or the seed has the presence of two layers. One called as the outer layer. Seed coat has two layers. One is called as outer layer called testa. The outermost layer of a seed is called as testa, and the inner layer of the seed is called as tegmen. So here two words. The seed has the presence of seed coat, and seed coat is of two layers. One is called as a testa and the other one is called as tegmen. So there are two layers. Next one. There is a presence of helium. So helium is called as a scar in the seed. So helium is a scar in the seed which helps in attachment of the fruit. Attachment of fruit. So helium is nothing but the joining part. It helps in attaching. Helium is the scar on the seed coat. Seed coat and helps in attachment to the fruit. Above the helium, there is a presence of small opening. The small opening is present. Above the helium, there is a presence of small opening, and this opening is called as micropyle. This is further giving rise to a seed coat. So within the seed coat, within seed coat, there is the presence of embryo. There is the presence of embryo. The embryo has embryonal axis. Embryonal axis is present, and it has the presence of two cotyledons. Along with embryonal axis, it has the presence of two cotyledons. So we know that in a dicot, two cotyledons have been present, and these cotyledons are always fresh and has full of reserve food. Reserve food is present. So here the cotyledon is always fresh or fleshy or fresh, and has the presence of reserve food materials in the cotyledons. Now we go for the next one. Two ends of embryonal axis has. So here ends of embryonal axis has the presence of radicle and plumule. So here there is a presence of embryonal axis. This embryonal axis has the presence of radicle and plumule. So we know that the radicle is always giving rise to root system. So the radicle is further developed and gives rise to root system. Whereas the next one called as plumule. So this plumule is further developed into shoot system. So here the radicle gives rise to root system and plumule gives rise to shoot system. Now we are stepping into seeds of two types. One is called as endospermic seeds. Seeds are of two types. One is endospermic. So the meaning of endospermic seeds. Here there is a development of endosperm. There is the presence of endosperm at maturity. When a seed is mature, and it has the presence of endosperm. So in the last class I have mentioned about the endosperm is foreign double fertilization. So here double fertilization takes place. Double fertilization helps in the formation of primary endosperm nucleus. Primary endosperm nucleus is helping in the formation of an endosperm. So the endosperm is present in the seed. That type of seed is called as endospermic seeds. So in a endospermic seeds, you can see example, one of this is castor. So we go for the second one called as non-endospermic seeds. The second one is non-endospermic. So the meaning of non-endospermic, here the endosperm is not present in the mature seeds. So endosperm is absent. Endosperm is absent in mature seeds. Mature seeds. So this is called as non-endospermic seeds. So non-endospermic seeds can be seen in the beans, pea and gram. In this, just we see there is a presence of non-endospermic seeds. So we are going for the structure of a dicot seed. So you may see there is a presence of two cotyledons. So both the cotyledons are being attached, and there is a presence of a small scar-like structure. There is a scar-like structure present on the seed coat called as helium. This helium helps in attachment to the fruit. And below this, or we say that there is a presence of a small pore opening called as micropyle is being present. So there is a small opening, and this opening is called as micropyle. Now, when you come to a dicot seed, when the cotyledons are elaborated or it is being spread out. So these are called as cotyledons, and it is being attached here, and there is a presence of a small two parts. Small parts are being present. One of the part is called as a plumule. So the plumule is always giving rise to shoot system. Below that there is a presence of radicle. So this radicle is always giving rise to root system. On either side of this there is a presence of two cotyledons are being present. So this is called as the structure of dicot seed. Now we are stepping into the next one called as structure of monocot seed. So we start with the next heading called as structure of monocotyledon seed. So we know that monocots has the presence of single cotyledon. So majority of the monocot seeds are endospermic. Majority of the seeds are endospermic. Some like orchids and Vallisneria, here the endosperm is absent, so they are called as non-endospermic. Non-endospermic. So majority of the monocots endospermic, orchids and Vallisneria, there is non-endospermic seeds. Next, when we go for the outermost layer of an endosperm, the outermost layer of the endosperm of an embryo, outer layer of endosperm of embryo has the presence of the proteinaceous layer. A proteinaceous layer, and this proteinaceous layer is called as aileron, or it is called as aileron layer. I repeat this. The outermost layer of an endosperm, there is a presence of an embryo is having the presence of proteinaceous layer. This proteinaceous layer is called as aileron layer, and it has the presence of one large shield structure. So here one large seal-shaped cotyledon is present. Seal-shaped cotyledon is present. One cotyledon is present. So here this cotyledon is nothing but scutellum. This is nothing but scutellum. So just it should be remembered. So here one large seal-shaped structure called as cotyledon is known as scutellum. And there is a presence of radicle and plumule. So embryonal axis has radicle and plumule. So the radicle is giving rise to coleorhiza. The coleorhiza in turn is giving rise to root system. The other embryonal axis is called as plumule. Plumule is giving rise to coleoptile that further give rise to shoot system. Now we step into the structures. So here the embryo is having the presence of, we call it as endosperm. Inside this endosperm there is the presence of embryo. You can write this diagram, but this diagram is important. So here this layer is called as, or this is called as endosperm. The endosperm is covered by a proteinaceous covering, and this proteinaceous covering is called as aileron layer. So this is present and it is covered by the seed coat as well as fruit walls. Next, coming to the other one, there is a presence of a large shield-shaped structure called as cotyledon. It is nothing but scutellum. So in this there are two words. One is called as radicle. So the radicle is always giving rise to coleorhiza. This is important in monocots. In monocots, the radicle is giving rise to coleorhiza. The coleorhiza is in turn giving rise to root system. In turn giving rise to root system, whereas plumule in turn giving rise to coleoptile, and this coleoptile is giving rise to shoot system. It is giving rise to shoot system. So this is about the structure of a monocot seed. So we start with the next study called as seed germination. So in a seed germination, there are two types of seed germinations. One is called as hypogene germination and the other one is called epigene germination. So when we start with the hypogene germination, when the epicotyle grows first. Once the epicotyle grows first, the plumule, is pushed out of the soil. Plumule is pushed out of the soil while cotyledons and the other parts remain in the soil or under the soil. Such type of germination is called as hypogene germination. I repeat this. In a hypogene, epicotyle grows first. And only the plumule is pushed out of the soil. The plumule is coming out of the soil while the cotyledons and the other parts remain under the soil. This type of germination is called as hypogene germination. Examples: when we go for monocots, maize, rice, coconuts are the examples of monocot hypogeal germinations. So when we go for a dichots, in a dichots, pea, gram, mango, broad bean, all these are called as dicot, examples of hypogeal germination. Now we go for the next one called as epigene germination. So the word epigene, when the hypocotyle grows first. Here epicotyle grows first, but here hypocotyle grows first and pushes the cotyledon and the other parts out of the soil. It pushes the cotyledon and the other part out of the soil. Hence it is called as epigene germination. So example for this is sunflower, mustard, cucurbita, castor, onion, tamarindos and French bean. All these are the examples of hypogene germination. Students, we are going for the next headings. So we have completed all the parts of the plant body. So we have completed root system and stem, leaf, inflorescence, flower, fruit, seed. So all the parts has been completed. Now we are stepping into the next word called as taxonomy. Before going into taxonomical detailed information, we are going to see some technical descriptions. So, semi-technical description of a typical flowering plant. So, we are going to see. So, we know that there is a presence of various morphological features of the person. The word morphological features means it is the external structures. So, morphological features are being describing one after the other. For example, so we are going to describe very briefly and scientific languages how to represent the plant, how to represent the proper sequences, how to represent the morphological characters in a proper sequences. Just we are going to describe this. So here the very first one is when you are describing the plant in detail. So first we always start with a distribution. So we are going to start with distribution. So the word distribution is nothing but where the plant exactly grows. So whether the plant is growing in a temperate region, whether they are growing in a tropical region, semi-temperate, Arctic. So like this, temperate regions or which region the plants are growing, based on that they are going to write the word description. The next one here we are going to represent is habitats. The word habitat is nothing but where the plant is dwelling. It is a dwelling place of a plant. So whether the plant is present in land called as mesophytes. Land is called as mesophyte or it is called as terrestrial. So whether the plant is present in the water called as aquatic. Whether the plant is present in the dry areas, we use the word xerophytic. Like this, we are going to write a habitat. Next to habitat, we are going for a word called as habit. So the word habit is nothing but the plant is either herb, shrub or tree. So whether the plant is herb, low level with a delicate stem, low level with a delicate stem, they are called as herbs. Medium sized is called as shrubs, or above this are called as trees. Now, a particular plant, whether it is herb, shrub or tree, we are going to mention this is the habit. After that, we are going for a root system of a particular plant. Root. So, how the roots have been present? Whether the root is taproot system or fibrous root system, and is there any modifications in the root that should be mentioned here? So, the roots may be taproot system or fibrous root system should be represented here, and some modifications, if there is any sort of modified or modifications are present in the root, that should be mentioned. For example, fusiform roots, or we call it as conical roots, naviform roots, all that may come under this. Next to the root, we step into a word called as stem. Here, we are writing in detail about the stem characters. Whether the stem is erect stem, drooping stem, horizontal stem, underground stem, or subaerial stem, all that we are going to mention here, and along with that, the modification. So, we call aerial stem, stem is erect, branching is there or not. So, branching is present or not. Whether the wood is present in the stem or not, woody or delicate stem, and if there is any modifications like thorns, hooks, spike, or we call thorns, hooks, all that can be mentioned in the modifications present in the stem. Whether the stem is underground also can be mentioned. Next to the stem, we go for a leaf character, leaves. So, in this we are going to start with whether stipules are present or not. So, if the stipules are present, we use the word stipulate. If stipules are absent, we use the word X stipulate. Whether the petiole is present or not. If a petiole is present, we use the word petiolate. If petiole is absent, we use the word sessile. Next we go for whether the leaf is simple leaf or a compound leaf. Simple leaf or compound leaf, that should be mentioned. And whether the leaf has what type of venations, that should be written. So whether it is called as reticulate venation or parallel venation. Reticulate or parallel venation, that should be mentioned. Along with that, we are going to write human phyllotaxy. What type of phyllotaxy is present? Whether it has the alternate or opposite or oral type of phyllotaxy, that should be clearly mentioned. Next to the leaf, we go for inflorescence. So again, here we are going to write what type of inflorescence is it. Whether it is a racemose inflorescence, in racemose, what type? Whether it is a simple raceme, umbel, corym, all that should be mentioned here. If it is a cymose, what type of cymes? So here, racemose or cymose, or is there any modifications, that should be mentioned. Next to this is flower. So we'll go for the next one called as flower. So in a flower, we are going to write all the characters of a flower. So whether the flower is having the presence of a stalk or not, whether the pedicel is present. If pedicel is present, we use the word pedicellate. If a pedicel is absent, we use the word sessile. Like this, we are going to mention pedicellate or sessile. Next, whether the flower is complete flower or incomplete flower. The meaning of complete, the flower is either bisexual or unisexual. That should be mentioned here. The flower is bisexual or unisexual. That should be mentioned. And then we are going to write a symmetry of a flower. So symmetry of a flower, either it is actinomorphic or zygomorphic. Actinomorphic or zygomorphic flowers, that should be written. Next, whether they are trimerous or pentamerous. Trimerous or pentamerous. So the meaning of trimerous, there is a presence of 3 sepals or petals, or we use the word 3 tepals. Here pentamerous, 5 sepals or 5 petals, that should be mentioned. Next, position of the ovary also should be written. Whether the position of the ovary is superior, inferior or semi-inferior, even that also we are going to mention here. So all these characters should be mentioned in a flower. Complete detailed characters are mentioned in a flower. Next we go for calyx. In a calyx, we are going to write how many sepals. Sepals are 5. Whether they are free or fused, that should be written, and whether they what type of estivations are being present, that also should be mentioned. Estivation, whether it is a valvular estivation, twisted estivation or imbricate, that also should be written. Next one is corolla. Again here, how many petals are there? How many petals are there? Whether the petals are free or fused, and again what is the estimation of a corolla, even that also should be mentioned here. So again the estimation should be valvular estimation, imbricate, twisted, like that can be written for a corolla. Next we go for antennation. So in this antennation, how many stamens are there? For example, if the stamens are 5, we are going to write 5 stamens. Whether the stamens has either only 1 lobe or 2 lobes. So for example, if it has 2 lobes, we use the word diapetus. For example, when a stamen has 2 lobes like this is called as a diapetus. When a stamen has only 1 lobe like this, it is called as monocots. Monocots. And how it is being fixed, whether it is fixed, base fixed, dots fixed, all that should be written. And again, whether they are free or fused. Free or fused, adult first. What type of adult first? All that should be mentioned in the annotation. Next we go for gynoecium. The word gynoecium is nothing but female. So here, how many carpels? Number of carpels should be written. So either it is called as monocarpellary, bicarpellary, pentacarpellary, all that should be written. And ovary. Again, we are going to repeat here. Ovary is either superior ovary or inferior ovary or semi-inferior or semi-superior ovary should be written here. And next to that, symmetry of a flower also written here. Symmetry, either it is called as actinomorphic or zygomorphic should be written in this. And again, you are going to write what is placentation. So, what is the arrangement of placentation? Either it is called as axial placentation or basal placentation, all that can be written. Next to this, we go for the word fruit. So, what type of fruit? Whether it is a drupe or it is capsule or it is called as berry. So, what type of fruit that should be written? Last one, we go for a seed. In a seed, whether it is a dicot, 2 cotyledons will be there. If it is a monocot, 1 cotyledons will be there. And whether the seed is endospermic or non-endospermic should be mentioned. Endospermic and non-endospermic should be mentioned. After the seed, we are going to write floral formula. So after seed, we are going for the next one called as floral formula. So here, as we know that some botany and some of the maths we have a formula. Same way, in a botany, in a taxonomy also, we have some formulas. How to write this formula? Just I am going to explain in detail. This is important for your exams also. So just listen how to write a formula based on all the characters, based on the flower and various characters. We are going to sort out the formula. If a bracts is present, if a bracts is present in a flower, we are going to write BR full stop. So BR dot, that indicates bracts is present. If bracts is absent in a flower, we are going to write EBR. So this indicates E bracteate and this indicates bracteate. So bracteate, a bract is present, BR. E bracteate means absence of a bract. Next one is BRL. That indicates bracteole. If a bracteole is present, we should write EBRL, BRL. If it is absent, we are writing EBRL. That indicates E bracteolate and this is called as bracteolate. Next, we are going to mention whether the flowers are actinomorphic or zygomorphic. Symmetry. Symmetry of a flower should be written. So when you write a circle and write plus, this is always called as actinomorphic. Actinomorphic. So this is not required to write. When you write a circle and plus, it's enough. That indicates it is actinomorphic. When you write a circle and write percentage at the center, this indicates zygomorphic. Only this much is enough. To make you understand, I am writing the labelings below. Zygomorphic. This is not required to write. Only this is enough. So this is called as zygomorphic. This is called as actinomorphic. And next, we are going to write the sex of a flower, whether it is unisexual or bisexual. So when you write a circle and write the arrow mark like this always indicates male. This is always indicates male flowers, unisexual flowers. When you write a circle and write plus, this always indicates female flower. Unisexual, female flower, this is called as female. So when you write both, if it is bisexual, so we are writing a circle, arrow mark with the below plus, this indicates called as bisexual. The flowers are bisexual. So that should be written. Next to this, after writing the symmetry, we are going to write the sex of a flower, whether it is unisexual or bisexual. After writing this, we are going to write the other floral parts. The word K is always called as calyx. The word K means calyx. Here, how many sepals are there? That should be specified. For example, if the sepals are 5, you should write like this. If the sepals are 5 and it is free, called as polysepals. So you are going to write without brackets. If the calyx is 5 and it is fused, you are going to write calyx 5 within the brackets. So this is called as Gamosepalous, and this indicates polysepals. So this is free 5 and with brackets. So these words what I am writing below should not be written. Only the representation should be written. The words what have been written below is only for your verification. So the word K called as calyx. When you write the word C, that is called as corolla. So again here also it is C. Corolla, how many petals are there? If it is 5 petals, you are going to write 5. Whether it is free or fused should be mentioned. When you write a word without brackets is called as polypetalous. When you write corolla 5 with the brackets, that is always called as Gamopetalous. So this should be written. Next to this, when you write a word A is called as Angiosperms. A is called Angiosperms. Again, in this, how many stamens are there? That should be mentioned. If the stamens are 5, you write 5. If it is free, nothing to be written without brackets. If it is fused, you are going to write the brackets. So it is called as free. And if the stamens are fused, called as monoadelphous condition, you are writing in the brackets. And when you write a line about this, C and A, when you write a line about this is called as epipetalous condition. Epipetalous condition. Epipetalous. That indicates the stamens are fused with the corolla. That is called as epipetalous. The next we go for a word G. The word G indicates dilution. The word G indicates dilution. Again, we are going to write how many carbons are there. So, for example, when we write 5, this is called as pentacarpillary. Again, after writing pentacarpillary, again it is free or fused. So, when it is written without anything, it is called as apocarpous condition. Apocarpous condition. When you write G and write within the brackets, that is called as syncarpous condition. After writing this, you are going to write the position of the ovary. So here, just see that when you are writing 5 gamopetalous below, when you write a line below, that indicates superior ovary. So here, once it is written here, that is called as superior ovary. So once you write the word G and write above and write 5, this is called as inferior ovary. Or when you write a G and write at the center and write this is called as semi-superior or semi-inferior. So here there is one more clarification. So whether the line can be written below the G or below carpillary. So if you want, you can write G5 below this or G5 above this or G5 in between this. Even this also can be written for the superior ovary or inferior ovary or semi-inferior. So this word should be written as a floral formula. So this is about the total semi-technical description of a morphological typical flower.